a Portland Community College mathematics telecourse. A course in arithmetic review, produced at Portland Community College. The addition of whole numbers. This lesson will assume that you can add whole numbers. We simply wish to take a few moments to examine that process. Let's recall the basic rule that when adding, we add together only digits of the same place. Many of us learn the rule that we learn up the ends. That's not the rule, and that can be dangerous when we get to decimals. It's not the ends that we line up, so much it is that we line up the ones digits, the tens digits, the hundreds digits, and the thousands digits. You might recall that in elementary school, many teachers had you mark those places to keep this idea very clear in your mind. Then, because we have memorized the addition table, we simply mentally add up the ones digit. So this is 12, 18, 22, 26. 26 now. But rather than writing the 20 here, we wrote it up here and the 6 down here. But see, 26. And the 20, of course, belongs with the tens or the next column. We recall that every time we get 10 here, it becomes 1 over here. 10 of these is 1 of these. 10 of these is 1 of these, and so forth. Now, mentally adding these up, we would think 10, 12, 17, 19. There's my teen, or 10, and 9. 19. Then adding the next column, 6, 10, 19. Then finally 4. And these tens digits from our adding we learn to call carries. A simple process, and that's the one process I'm sure that most people remember quite frequently, having done it so much in their lifetimes. Frequently, in business or science documents, you'll find your addition problem written horizontally. Some people will actually learn to add horizontally. It's not a bad trick to learn. Most of us, however, prefer them written vertically. So let's write this vertically, keeping the units places and the tens and the hundreds places lined up, like this. And if it will help you to draw lines to keep your place values straight, then do so. After all, most accountants do this, and they're the professional ones at using numbers. Then add quickly in each place column. If you have difficulty in adding, there are many, many tricks to memorizing additions and learning to add in different arrangements than this. It would take fully an hour or 2-hour tape, which we don't have time for. So if you need some assistance in memorizing your additions table, then see the specialist at your school. There are many, many devices that can be used for this. So adding vertically very quickly, we have 13, 22, 28, 34. And the 30 comes to the next column as a carry. Then 5, 10, 18. See that teen came over here as a carry. Then 5, and you're done. You should be able to go just that fast, and if you're going to be really professional, like an accountant, faster. And of course, nowadays, much of your arithmetic is done on calculators. So it might be handy if you have a calculator with you in this course and learn to use it simultaneously. Now, of course, in the calculator, these operation signs plus become a button to be pushed. And when you're all done pushing the buttons, you wish to know what the answer is. So on most calculators, the equal sign 2 is a button. So it's simply a matter of pushing these particular buttons. The button 25. So 25, the button plus 8 plus 359 plus, now let's get this up to where you can see it better, 86 plus 106 then equals 106 equals, and we have the results 584. Now that sounds so easy, seems so easy. You might ask, why are we doing it by hand? Of course, if you have your calculator, use it. But there's an interesting fact that studies have found. Studies show that a person who makes frequent mistakes in hand arithmetic makes even more on calculators. So therefore, just because we have worked this problem with a calculator does not guarantee that it's correct. However, a calculator's main function is to increase your speed. So having done this problem so fast on the calculator, it takes but a few more seconds to clear the calculator, back off, and redo it once again to confirm our answer. Therefore, always do all calculator computations at least twice, which I just did, and it checks. Always twice, at least. Now, of course, on a job or in personal daily life, most problems will be given to you in words, what some people call story problems, word problems, or application problems. So in fact, you not only have to be good at the basic math processes, but your language must be fairly good. An example, the Alvarez family has the following payments to make each month. The rent, $430, TV, $28, a new stove, $78, car payments, $105. What is the total of the payments that they make each month? Now, in all these words, there are one or two key words. In this case, total. Total simply means I want the results of having added, and I want the results of having added payments. So we simply identify all the payments, and that's what we're going to add. So here is our problem written in more traditional form. Note that we've kept the ones digits in a column, the tens digits, and a ones digit, the hundreds digit. Now we can add these either on a calculator or by hand. There are many tricks to add quickly mentally. Perhaps your teacher will show you a few, and if you're watching one of the extended lessons, we'll show you a couple next. But adding this, we would get 16, 21, carry the 2, 5, 7, 14, carry the 1, 6. So the total Alvarez bill is $641 per month. Now we leave it to you to do enough problems to become comfortable and fast. As in baseball or pinochle, your comfort and your accuracy is purely a matter of tons of experience. Even a dozen problems won't do it, but ultimately hundreds of problems. Where does the process or idea of carry come from in long addition? Later courses in number theory or algebra will examine this more formally, but by using the abacus we introduced in the last lesson, we can actually see very clearly why we carry the way we do. If we recall that what we do with our numerals on a piece of paper is simply a symbolic representation of what we used to do with beads. So let's examine what we now do symbolically. Adding our units column by having first memorized the addition tables, we would get 10 plus 5 is 15, and we would write the units digit here and carry the 1 or 110 to the next column, and that's what we want to examine. But adding here we get 10, 18, 26, writing the units digit here, carrying the 2 or 20 to the next column. We would get 6 and 7 is 13. Again, the units digit here, carry the 1 to this column, and of course in that case it falls straight through. Let's look sort of historically at where these carries come from and why they go to the next column. Recall that the abacus was used successfully for many, many centuries before our ancestors actually realized that these symbols stood for single large numbers. This 95 to them simply meant put 5 beads in this first column, which we have there. Then put 9 more beads in this column, which we learn to call the tens place or tens column. So there we have it. We'd have to scoot it down to see, but 9 and 5. Then only much, much later, actually centuries of time, did we think of this as one number, 95, and begin to write it in this manner. Then this expression merely meant to this column produce 6 more beads right on top of these. We were literally adding them on top. So 6 more beads here, 2, 4, 6. Then in our second or tens place, add 8 more beads. So adding 8 more here. And then put 4 more beads here. Of course, there are no beads at all, and we put 4 more. But recall that our ancestors' one feat of abstraction at this point was to realize that every time I get 10 beads here, or a hand of beads, they move back and became 1 over here. And 10 here went back and became 1 over here. So here we obviously have more than 10. So if we were to count off 10, 2, 4, 6, 8, 10, our rule of clearing says those 10 go back and become 1 over here. And the same thing over here. If we have 10 here, 2, 4, 6, 8, 10, that goes back and becomes 1 over here. So each time we get more than 10 here, for each 10 that we have, it becomes 1 bead over here. So if I had 2 groups of 10 here, that would become 2 beads over here. So continuing with our problem, this says place 4 more beads here, 8 more beads here, and we produce 8 more, and 7 more beads here. But again, for every 10 we have in any column, that becomes 1 in the next. 10 in this column, 1 in the next. So literally when our ancestors were adding, they were adding beads, not numbers, with the one rule that every time you get 10 here, clear it, and becomes 1 over here, which we now call carry. If you have more than 10 here, clear it and carry 1 over to here. Then when they were through adding beads and clearing groups of 10 and carrying, they would simply write down their finished results. So I have 1 bead in this column, 3 in this, 6 in this, and 5 in this. And this is exactly what it meant to our ancestors. 1 bead here, 3 beads here, 6 here, and 5 here. Only after many, many centuries did we finally learn to treat this as one number, 1,365. But can you begin to see physically where this idea of carrying came from and why it's always in groups of 10 that we carry? And of course that's because we counted originally in our hands, which have 10 fingers. We could have cleared by a different rule, but our numerals would then stand for a different numbers. And we will leave that for special courses that you might take in the future. Keeping this abacus in mind and how this works, that is, for every 10 in one column, it becomes 1 in the next, let's show you a shortcut that one could apply to adding long columns of numbers. First, to keep the column straight, frequently helps if you take your rule paper and turn it sideways, and now we have some free columns for better representing our columns of numbers, or our place values. Now, there are quite a stack of numbers even for a calculator. But let's look back at our addition facts and think about them a little bit differently. For a moment, when we see something like 5 and 8, let's not think 13, let's just think 3, and let that teen simply be a sort of a side thought. So 5 and 8 will think 3 with a teen over here. 7 and 7 is 4. Of course, 8 and 1 is still 9, but 9 and 4 is 3, with that teen coming over. And remember from our abacus that teen always goes to the next column. Generally, when a person has difficulty with adding a long column of numbers, it's not the number of numbers that's bothering him, because at any one moment you're only adding 2 numbers, 7 and 5, that's just 2 numbers, which is 12. 12 and 7, that's only 2 numbers, which is 19. 19 and 4 is 23, just 2 numbers. So at any one moment, on paper or mentally, you're only adding 2 numbers. So what really bothers one with a long column addition is holding in your mind all those carries. Well, let's think about that a moment. All the carries ultimately are going to come over to this next column anyway, so let's think this way. 7 and 5 is 12. Well, that teen will come over here, so I'll just put a little tick mark here. 12, that leaves 2. Let's keep going with just 2. 2 and 7 is 9. 9 and 4 is 3. Actually, it's 13. Teen comes over here. 3 keeps on going. 3 and 8 is 11. Teen comes here. 1 keeps going. 1 and 4 is 5. 5 and 2 is 7. 7 and 9 is 6 with that teen. Now forget these just a moment. We've got them already over to the next column where they're going to go. So with a little bit of practice, you'll actually go this fast. Now watch me here. 8 and 9 is 7. 7 and 3 is 10. 6 and 7 is 3. 9. 9 and 3 is 2. 2 and 8 is 0. Now can you see what I was doing? All of these marks are the teens, and I just took the units digit and kept on going. 8 and 9 is 17. Teen, took the 7, keep on going. 7 and 3 is 10. Teen, 0, keep on going. 6 and 7 is 13. Teen, take the 3, keep on going. 3 and 6 is 9. 9 and 3 is 12. There's my teen, 2. 2 and 8 is 10. There's my teen, 0. So with very little practice, you're going like this. 1, 5, 3, 2, 8, 3, 6. Now all of these tick marks, they're 1, 2, 3, 4 here. Well, they were the carries that were coming over to this next column anyway, which is where I put them. And here I have 1, 2, 3, 4, 5 that was coming over to this column. And here I have 1, 2, 3, 4, which was coming to this column. So I'm adding all of my carries when I'm done rather than as I go, and that saves me having to hold them in my head as I go along. Rather than holding in my head, I was just putting them down here one at a time as I get to them. So now I get 6, 4, 11, carry the 1 in this simple case, and I get my answer. With very little practice, one can make this procedure enormously fast. Interestingly enough, after I was done, I added these columns of numbers on a rather large, sophisticated calculator, and of course I got the same numbers. But originally, when I added on the calculator, I got a different number here than I did on paper. So naturally, your first thought is, I made a mistake here. But actually, the mistake was made on the calculator, not here. Again, the point that we made at the beginning of this lesson. For a beginner on a calculator, you will tend to make more mistakes on the calculator than you will by hand. The calculator is simply quite fast. So after doing it once on the calculator and writing your answer down on a piece of paper, then clear it and do it once again to see if you can verify the same answer. And you'll be surprised how accurate your hand arithmetic is to your calculator arithmetic until you've had much experience with the calculator. Again, let us remind you that if you're adding numbers which are given to you in a row, as they usually will be in written documents, if you're going to rewrite them in column form, do remind yourself to keep the places lined up. See, here we have the units all in the same column, the tens all in the same column, the hundreds and the thousands. But again, see how your eye begins to want to wander? So again, it's to your advantage if you either turn your paper on end or give yourself some clear columns in which to work. Then if you're using this trick that we just used, every time you get over 10, you'll put the 10 over into this column as a little tick mark and keep your units digit and keep right on going. So 5 and 6 is 1 with a teen over here. 1 and 4 is 5 and 9 is 4 with my teen over here. So 4 and 8 is 12. 2 keep on going. 2 and 8 is 0. Then I have 1, 1. Here I had 1, 2 coming over to here. And here I have 1, 2 coming over here. And of course, some of you might prefer to just pick these teens up as you go down the column. That's fine too. Or another trick that many of you might have learned in your early school years, particularly with long columns of numbers, is to scan the column first and find combinations that will give you 10. So there's 10, which I bring over to this column. Now, do you see any other combinations that will give you 10? There's another 10, and that will leave you now with 7 here. Then scan this looking for combinations that will give you 10. Well, there's 1. There's 1. And now if you don't see any others, then just add what you have, including these carries. So there's 1, 6, 14, 21. Now over here, look for combinations of 10 once again. There's 10, 8 and 2 is 10. 5 and 5 is 10. Okay, no more obvious ones, so there's 2, 7, 11, 15, carry the 1 again, and 3. So see, here we've shown you 2 tricks, looking for combinations of 10, or just straight out addition, but every time you get a combination greater than 10, you put the teen here, take the units digit and keep on adding till you get another teen, then you add all the teens in after the fact. Use these shortcuts if they seem convenient to you. If you're one of the fortunate students that can simply add straight out and carry in your head, then you will probably want to stay with that kind of an approach if it's been giving you so much success for so many years. For instance, a really experienced person would simply think this way: 7, 15, 24, 25, 32, 11, 14, 16, 20, 29, 7, 11, 20, 27, 35, and possibly even faster than that. So if you're one of the fortunate few that can add in that manner and that quickly, we say, bless you, stay with it. But all of these techniques are predicated on the underlying assumption that you have your addition table and later your subtraction and multiplication tables memorized. Do you? If not, then do see your instructor or your school's tutorial center. Let them know that you don't have these tables memorized so that they can give you the extra help, drill, and outside practice to have these basic tables memorized. It's the start of all of our thinking in arithmetic. Without it, it just isn't possible. But do you get a feel for how man has gone from the abacus to counting beads to carrying to eventually memorizing a table, which is simply the memorized results of what happened on this beadboard? Then from there to doing in our minds what this did, and then finally through all of that to the calculator and computer. So practice, and use the practice as a bit of a lubrication exercise for your thinking, so that as we move into more advanced arithmetic and later algebra and business math, you're quite smooth and comfortable in these basic operations. So until your next lesson on subtraction, this is your host, Bob Fennell, saying practice and become comfortable. We'll see you then.